In this video, I want to talk about some of the concepts and trends that have been appearing and really sticking around in the field of drafting. So, as I've mentioned quite a few times, and you'll hear me say more and more throughout the course, that drafting has really evolved quite a bit from what it started as to what it has become today. While the content of the drawings that a draftsman makes are the same, the way we go about it, and particularly the way we design things, have really changed into a lot more of a computerized system. And then we've even brought in automation in a lot of concepts to kind of help speed the process up more and then really allow us as designers to come up with things that would be much harder for kind of our small little human brains to comprehend, or at least my small little human brain. And so some of those concepts that we've brought into play are things like CAD, CAM, CNC, BIM, and rapid prototyping, which we'll look at in a bit. And it all has started to fold now into the trend of sustainability, which will be our topic of discussion for this presentation. So, the first major trend that started and is going absolutely nowhere, so I wouldn't really necessarily call it a trend anymore, is computer aided design, or CAD. So, CAD tools and software allow us to create digital versions of our drawings that we would be creating by hand. So, throughout this course, we'll start doing our drawings through hand drawing techniques, and then we'll move on to CAD systems. And there's really kind of two reasons for that. One is I find it's easier for students to comprehend and understand the drawing techniques when they do them by hand, as just kind of starting out. And then the other reason is to kind of give you an appreciation of the things that that computer can do for you. So once we move on to the CAD concepts, you can work so much faster throughout a drawing, and to make changes to that drawing is so much easier on the computer, and your drawings come out much cleaner, much more professional looking. So hopefully having that experience doing them by hand, even if we are going to just do it for a short period of time, will hopefully give you a little bit of an appreciation for how much faster it can be to come up with those drawings virtually on the computer. And there's now lots of different CAD softwares out there that a drafter can use to create their drawings on the computer. To branch off of CAD, there's also CAM, or computer aided manufacturing. So CAM systems are based off of those CAD drawings, whether it's a 2D drawing for a tool path or a 3D drawing for what's called a CNC machine. We can take those digital drawings that we've made, or 3D digital models that we've made of something, and we can put it into a machine where it'll create our part for us automatically. So a lot of CAM's machine operate as CNC machines, which stands for computer numeric control, and essentially the machine moves based on coordinates of where it needs to go on an XY plane, and then how far up and down it needs to move. There's lots of different types of machines out there that can run on CNC or G code. So really, if it's a machine that can be operated by hand, then there is a computerized version of it now. So there are CNC mills, lathes, all different types of machines kind of operate now. And this is really what a lot of manufacturing is based off of. But there's still a need for people to program the machines, to operate them, to provide maintenance to them, to check everything that operates within them. So this actually would be where I got kind of my start in the drafting world, was that I started off as just kind of a CNC operator that I just was there monitoring the machine and checking the parts that came out of it. And I noticed as the screen went by that different pieces of code prompted the machine to do different things. And then I kind of got more into creating the 3D models, programming the machines and everything. And it's a really interesting part of manufacturing, but it makes it so much more efficient, and it takes out a lot of that human error that could come into play when it comes to manufacturing equipment. So CAM is a great tool for creating all of our different products. Now, if we use CAM and CNC on that kind of manufacturing side and that production side, on the architecture side of things, we'll use what's called BIM, or Building Information Modeling. So BIM software creates a 3D parametric model, or model that's based on specific conditions, that can manage a lot of different data related to the building. So more than just creating the drawings of the building, it can also track data such as lighting schedules, material cost, volumes of rooms, and then we can even get other data out of that, and we can do energy analysis on a building within a BIM software. So we can pretty much calculate an estimate of how much energy a building would use, how much it would take to heat and cool the building. We can figure out geographically where the building is, and then do solar analysis of how much sun the building will get. So then take that into account of how much energy we can potentially save regarding that. So there's lots of different pieces of data that's associated in those BIM models, and that's where that information part comes in. So you can do a cost analysis based on just what materials are purchased, and what types of windows are being used, and square footage, as well as just all of these other different kind of analysis based on energy and things like that. So one of the major pieces of software associated with BIM is a piece of software like Revit. And so if you take Drafting 2 Architecture, which currently is only offered in person at the school, you'll learn the software Revit, and that is kind of the main player when it comes to BIM. And then again, piggybacking off of the CAM and CNC concepts is another trend that's been gaining more and more popularity as time goes. It's kind of hit a little bit of a plateau right now in the 2020s, but is rapid prototyping. So those are things like 3D printers and laser cutters, where we can make kind of quick prototypes. So maybe not the official end result product, but come up with a prototype or a model of a building or a product to just kind of visualize it physically, to maybe test the ergonomics of it, which is just kind of, how a person interacts with it, holds it. Is it comfortable? Is it easy to use? And just evaluate a design a little bit. So we have some of these things in the in-person classroom. We've got some 3D printers to either just make some small little trinkets or keychains, which I can have those made within about 30 minutes versus some larger models may take upwards of hours. And a laser cutter as well. We have one of those at the in-person classroom, and we'll use those a lot for making architectural models, or just kind of personalizing different pieces, or making cardboard prototypes of objects. Using technology, rapid prototyping technology, we can kind of get to a more successful end product a little bit faster, because we can use cheaper materials to make these prototypes and test them out. And we also just can kind of, see if physically it's a design that's either appealing or a design that works without having to go through the manufacturing process that we would have to for making a product, especially because when you think about the design aspect, in order to use those pieces of CNC equipment to mass produce something, in order for it to be cost effective, it has to be something that I'm making a lot of. And that's not really an issue. So, for instance, just because I'm looking at one on my desk, if I wanted to manufacture a nail polish bottle and I needed to just make sure that my design, that the screw top worked and that the brush was a good size and that it fit the right amount of polish, that's still going to take a lot of setup to mass manufacture, to kind of set all of the machines up and everything. And so it would make more sense for me just to kind of test everything with, a 3D printer just to make sure the design looks the way I want it to and that it can hold the amount of polish I want, that the top screws on effectively. Test all that stuff out with a 3D printer where I can only make, one or two objects. And then once I have everything exactly the way I want it, then I can go and send it to the manufacturer to make all of the different products. So rapid prototyping technology has made it a lot more cost effective to kind of go through that design process and get to end products that we want. Now, the big trend in drafting is, and this is in both the engineering field and the architecture field, is sustainability. And sustainability really focuses on creating buildings or products that have a mostly positive impact or a zero impact on the environment. That's what we really focus on when we think of sustainability, is environmental factors, but really sustainability is more than that. So in order for something to truly be sustainable, it should have a lesser impact. The ultimate goal is to have a positive impact, but really one thing you'll notice if you start studying things related to sustainability is that it's very hard to have that positive impact, but it's a better option to go for, well, this is less bad than what we currently have, and then continue to try to strive for always being less bad. But true sustainability would be in the environmental aspect, social aspect, and economic. So it should be something that doesn't cost too much. It should be something that doesn't cause harm to people. And it should be also something that doesn't cause harm to the environment. And while the concept of less bad maybe isn't the best, it's still better than thinking of nothing. So sustainability is a big hot topic in the field of design now, to try to make things that are kind of a little bit better for the world. So in relation to sustainability in architecture, there is an organization called the U.S. Green Building Council, and they have a program called LEED, which is Leadership in Energy and Environmental Design, which is a program in which you can sign up to have your building evaluated and become LEED certified, to celebrate these practices of sustainability and just kind of environmental consciousness within architecture or buildings. So some things to consider regarding LEED certification is that it's based off of different areas. So there's different categories within LEED certification in which essentially you're earning points for. And you can look at these scorecards and these points on the US GBC website. But they have different categories. So category energy and atmosphere is related towards the energy usage of the building, using renewable energy sources and just reducing energy uses in the building in total. Water efficiency, which is again about reduction of water and potentially reusing water in gray water systems. Sustainable sites, which is thinking about the ground or the site that the building is on. Indoor environmental quality, which is thinking about the air quality, the lighting. the temperature within the building, and just the inside of the building in general. How comfortable is it for people to be in? In my opinion, I did a lot of research in my graduate studies about LEED, so I'll get on my soapbox. In my opinion, the indoor environmental quality should be the most important part of a building, because if a building isn't comfortable to be in, then who cares how much energy it's saving? But I won't stand on that soapbox because then this video will never end. Materials and resources, which is just the materials that the building is made out of. Are we using sustainably sourced products where, you know, I do have hardwood floors in my building. However, where I'm purchasing them from, they have a system in place where they plant trees for the trees that they harvest, or am I using recycled materials in my building? And then there's also a category for regional priority or just innovative measures. So some buildings may gain extra points for doing things that are particularly important in that region. So, for example, if it was a building in California, I'd get extra points for reducing water consumption, because water is an extremely kind of high priority resource in places like California. Um, the other thing to consider with these categories and just kind of how buildings are evaluated within the LEED system is that different types of buildings are evaluated differently. And so, for example, I'm not going to judge somebody's house the same way I would judge a hospital, because those are going to have different needs for the building itself. Um, and I can't remember, even though I didn't make this too long ago. Oh, no, I did. And then, so based on what different systems you put in your building to kind of cover some of these sustainable concepts, you'd get rated at a different level. So how many points you get on your scorecard in the end. You can become either certified, silver, gold, or platinum. And buildings, when they're going for LEED certification, they know already before they even apply for it that they want to get LEED certified, and they'll typically even know which level they want to get to, and they'll know which points they're going for on that scorecard. So Watauga High School itself is LEED certified, and we have a silver certification rating. And the reason why, like, ultimately, would we want to go for platinum? Sure. But the thing is, to put those systems in place to get those higher levels of certification is going to cost more money. And so ultimately, as a school, during construction, we had a budget that we had to follow, and we had things we needed to consider. And so we kind of went for different trade-offs of which areas did we find most important as a school to put in place to get that silver rating. And I have in the discussion post, I'll have a link to just like the school scorecard in general. If you want to look at things more involving LEED, or if you want kind of more information about LEED, feel free to email me, but I don't want to talk about it too much, because then by golly, I won't shush up about it. So kind of to tie into what we're going to be doing in the discussion post is, here's a quote from Bjarke Ingels, who is an architect who focuses a lot on green design. And right there is a link to his TED Talk where this kind of comes from, is that architects, and this can apply for engineers and designers as well, is it's more than just designing this two-dimensional facade of just the outside of the building and how it looks, or just like the three dimensions of the building and how we walk through it. Is that architects and designers have to design ecosystems. It's the system of how ecology and economy that channel not only the flow of people through cities and buildings, but resources like heat, energy, waste, and water. What he's talking about there is designing buildings is more important than just thinking about how much the building cost and how comfortable it is for people to be in, but also the resources, the environmental resources that the building is consuming and potentially putting out as waste. So when the architect and designers really think about that product from its initial start point to then its end of use and what happens at its end of use, that's when we can start designing the most sustainable products. There's another designer out there that I don't have linked in this presentation, but his name is William McDonough, and he has a concept called Cradle to Grave, in which he designs things for cradle to cradle. So cradle to grave means designing products from their very initial start point into then they eventually go to a landfill. And he thinks of products as, okay, once it's created and started, how can we design it so that once this product reaches its end of life or end of use, it can be made into something else. And so that is the ultimate kind of concepts of sustainability and using the resources we have in the best and smartest way possible. So for this little discussion poster presentation, we have seen that a lot of technology and just trends of drafting are pushing towards this concept of we want to make things faster. So that's why we've brought in technology like CAD and then those CNC systems so that this way we can push things out faster. And then a huge push towards sustainability of having that conscious impact on the environment, on people, and on the economy. So a lot of people feel that this push towards sustainability is like that is just the new standard for the field of drafting and manufacturing and architecture, but others feel like it's maybe just kind of a buzzword or a trend that is going to die down at some point. So in the discussion post below, I just like for you to kind of maybe look into the concepts of sustainability when it comes to design and state how you feel about it. Do you think it's just a trend that isn't going to last very long, or do you think it's something that should become the new norm, and justify your opinion? And then when it comes to sustainability, what of those three areas would you think would be the most important to keep at the forefront when designing? Do you think the environment would be the most important? Do you think the economic or kind of the bottom line when it comes to cost would be most important for a product to be sustainable? Or do you think its impact on people would be the most important? And again, why? So there are no wrong answers in this discussion post. It's just you are going to just do a little bit of reading and then post what your opinion would be. And so then to post, you'll just put your reply in the discussion and make sure when after you post to reply to at least one other student's discussion post. And I'll have in here just kind of a little demo one from me for you to read and reply to as you see fit.